Alright, so we've been talking about relations and functions for a while, like pretty much all year. So today we're going to talk about inverse functions and relations. So our objectives are to answer the question, what is an inverse or what are inverses? And then we're going to find the inverse of a relation and the inverse of a function. And we're going to look at what it means to be an inverse. And then we're also going to look at them graphically, and we're also going to rewrite the functions. So for our vocabulary, if a relation pairs element A of its domain to element B of its range, the inverse pairs B with A. So basically you're just interchanging your x and y values. So if AB is an ordered pair of the relation, then BA is an ordered pair of its inverse. If both the relation and its inverse happen to be functions, they are inverse functions. So if one of them is not a function, then it's a relation. For a one-to-one function, it is also true that each y value in the range corresponds with exactly one x value in the domain. So it's a one-to-one comparison. So what's the inverse of relation S? So here I have my x values are 0, 2, 3, 4, and my y values are negative 1, 0, 2, 3. Okay? An inverse says we just take and we flip our x and y values. So our inverse is actually x is negative 1, 0, 2, 3, and y is 0, 2, 3, 4. Pretty easy, right? Okay, what about this? What are the graphs of S and its inverse? So here we have S. S is 0, 1, 2, 0, 3, 2, and 4, 3. First of all, what is the inverse of S? Well, we just change all those values. So we have our inverse is negative 1, 0, 0, 2, 2, 3, and 3, 4. So let's go ahead and just graph both of these and see what happens. So let me make a graph here. 1, 2, 3, 4. Okay, so my S function I'm going to do in blue. So 0, negative 1 is here, 2 zeros here, 3, 2 is here, and 4, 3, 3, 2. Oops, 3, 2 is down here. There we go. And 4, 3 is here. Okay, so this makes a line, kind of a line. Apparently I can't draw very good lines. Who would have thought, right? Alright, and then our inverse. We have negative 1, 0, 0, 2, 2, 3, and 3, 4. That's a terrible line. That's really, really terrible. Okay, let me try this again, because we need to actually be able to see. Oh, here's what I'll do. Sorry, I'm just kind of wasting your time. So we have 0, negative 1, 2, 0, 3, 2, 4, 3 as our function, and our inverse is negative 1, 0, 0, 2, 2, 3, 3, 4. Oh, that might be why, because, nope, I'm good. Okay, let me pull up a grid. Like that. Let's give me a guide to go off of. See, I can't even draw a straight line on a straight line. That's really terrible. Okay, so my points are 0, negative 1, 2, 0, 3, 2, and 2, 3, up, 3, 2. Still can't draw a line. And 4, 3. Okay, so it kind of does this thing. That's fun. Alright, My other ones are -1, 0, 0, 2. Stop. There we go. 2, 3. And that's not 2. My goodness. I am just not on point today. And 3, 4. So this one kind of does that thing. There, that looks much better. It's not exactly a line. Say, what do you notice about these two functions? Well, right through this middle, we're making a mirror image. See how that's a mirror image? What is this line? Well, it goes through 0, 0, has a slope of 1, so it's the line y equals x. So functions will always make mirror images. They're inverses. Inverse functions always make mirror images across that line, y equals x. Okay, that was, the hard part. Okay. So finding the inverse. What's the inverse of the relation described by y equals x squared minus 1? Now, if you want to find what an inverse is, instead of switching the values, the x and y values, you actually switch the variables, the x and y variables, and then you solve for y. So we're going to take and rewrite it as x equals y squared minus 1. And then we're going to go ahead and solve this equation for y. So to solve for y, the first thing we do is we add 1 to both sides. So x plus 1 equals y squared. Then we take the square root of that. So y equals plus and minus the square root of x plus 1. Because remember, we have both a positive and a negative root. That is the inverse of y equals x squared minus 1. So what's the inverse of this one? Y equals 2x plus 8. Well, first thing you do is you switch your variables. X equals 2y plus 8. And then you solve for y. Subtract 8. 2y equals x minus 8. Divide everything by 2. Y equals 1/2 x minus 4. That is our inverse of y equals 2x plus 8. Pretty fun, right? Alright, let's consider this function. F of x equals the square root of x minus 2. What are the domain and the range of f? What are my values so that f is a real number? Well, if I have anything less than 2, I'm going to have a negative number. Can we take a negative square root and get a real number? No, we get imaginary numbers. So that means our domain has to be anything greater than or equal to 2. And that makes our range, our y values, 0. So if it's 2, 2 minus 2 is 0, square root of 0 is 0. That's our range. What is the inverse, or f to the negative 1? That's what that means. The inverse of f. Well, to find the inverse, we take and we switch. Instead of f of x, replace that with y. Remember, f of x and y are interchangeable terms. When it's f of x, it just means this is a function. So we exchange x and y, and then we solve for y. So the first thing we do to solve for y is we square both sides. So we get x squared equals y minus 2, add 2, x squared plus 2 equals y. And we have to go since we use our range is greater than or equal to 0, now our domain is greater than or equal to 0. What are the domain and range of our inverse? Well, our domain is the same as our range of our first one, and now our range is the same as our domain was of our first one. So we have to just switch the two. Is f inverse a function? Is x squared plus 2 a function? Do you remember doing when we did parabolas this year? Were parabolas functions? Yes, as long as they're y equals x squared. So for every x in the domain, there's only one y. So it is a function. Well, that's it. Pretty easy lesson. Hope you had a great time. I sure did. Hopefully by your next video, I won't sound like a congested man anymore. Have a fun night. Okay, bye.